Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to be looking at solving linear equations. So to do that, we have some various examples here to make sure you remember the rules and the steps of what you're supposed to do. So as we move through these three slides, we're going to craft our rules one by one. So let's go into our first example. So in our first example, we have a question asking you to solve for x. Now, when they say solve for x, essentially what they're asking you to do is to isolate the x. In other words, x wants to be alone, and he wants you to get rid of everything around him. Okay? So your first move is, and your first step here is to isolate x. Okay, this is the first step for now. How do we isolate x? Well, you're basically going to do this by doing reverse BEDMAS. What does this mean? This means that you want to get rid of any additions or subtractions first. You then want to get rid of any divisions and multiplications, and then any brackets or exponents. Okay? So the first thing you want to look for here is you're going to notice right here that you have a -3 and a 7. These are the two things that are bugging my x. So what do I do is I want to get rid of the -3 first by adding 3 to both sides. So the only way to get rid of something is to do the opposite operation. So you want to get rid of someone negative in your life, get yourself a positive influence. So that's going to give me 7x is equal to 7. Then you have 7 times x. How do I get rid of the 7? Well, how do you get rid of that clingy best friend? You divorce yourselves by dividing both sides. So that would leave me with 7 divided by 7, which is 1. X is now by itself. We've isolated the x. So therefore, x is equal to 1. Okay. Now at any point, you should be able to pause the video and try to do the other examples if you are able to. Okay? Are you back with me? Great. So looking at this second example. Now once again, if I'm following my rules, I want to reverse BEDMAS. So I want to get rid of any addition or subtraction first. So I see a +2 here, and I see a division of 3. So remember, you want to do the opposite operation. So the opposite of +2 would be a -2. How do you get rid of positive influence? By putting a negative influence. All right. So that's going to give me x over 3 is equal to 11 minus 2, which is 9. Now you have a division. To get rid of the division, you need to multiply both sides by that number on the bottom. Now once again, you're not multiplying the bottom by 3. You're multiplying the top by 3, which helps to cancel out those 3's, leaving you with the x is equal to 9 times 3, which is 27. And finally, in the last example, once again, you're going to follow your steps. You want to always follow your steps. And the first step, once again, you want to do reverse BEDMAS. So the reverse BEDMAS here would say I want to get rid of this -4. So I'm going to add 4 to both sides. It's going to leave me with 3. X plus 2 is equal to 9. Now, here's the problem here. Now, people are going to look at this and say, Sir, you said get rid of all additions and subtractions first. But there's an addition in here. That's true, but it's within a bracket. So because it's inside a bracket, you need to get rid of that bracket first. And how do I get rid of it? By getting rid of this 3 that's multiplying the bracket. So 3 is multiplying, which means I would divide both sides by 3, which would give me x plus 2 is equal to 9 divided by 3, which is 3. Now you can get at that plus 2 by subtracting both sides by 2. And finally, x is 1. Now that's one way of doing it. There is a second way of doing this. So I'm going to write the problem again here. The second way of doing this is the good old Pokemon Go way. So you would expand first. Okay, so expand first. Giving you 3 times x, which is 3x, plus 3 times 2, which is 6, and then that minus 4 out there. Then you want to collect your like terms. Okay, which would be the 6 and the minus 4. So you're going to end up having 3x plus 2 is equal to 5. Now you want to come back to follow these reverse BEDMAS rules. So I'm going to subtract the 2 for both sides, leaving me with 3x is equal to 3, and then divide both sides by 3, leaving me with x is equal to 1. So no matter what, you're still going to end off with x is equal to 1. Alright, so let's move on to the next example. Now in this next case for solving for my x, you're noticing there is a difference here. The difference is the x is now in the bottom rather than the top. What do I do? Well, the first thing you would do is bring x to the top. Alright, and how do I do that? By multiplying both sides by the x, which would leave this x to go away and leave you with the 5 there, giving you 10x on this side. Now you just follow the reverse BEDMAS rules, divide both sides by 10, leaves you with x is equal to 5 over 10. Now at this point you're still not done, because 5 over 10 is not the simplest it can go. You can divide the top and the bottom by 5, which means my final answer should be 1/2. Always make sure to simplify fully. Alright, that brings us to our second part of this example, where now you still have the x on the bottom, but you have 2 fractions, and these 2 fractions are equaling each other. In this case, there's something you can do called cross multiplication. So this x is going to multiply the 5, giving me 5x is equal to, the 3 is going to multiply the 7, giving me 21. Now you want to get the x by itself, so you're going to divide both sides by 5. So therefore, x is 21 over 5. Now I know some of you would be tempted to write this as a decimal number. Now, in mathematics, especially grade 9 onwards, we don't like seeing decimals unless the question tells you to give me a decimal. Alright? So you can write this as 21 over 5, or you can write it as a mixed fraction. So the mixed fraction there would be one big giant 4, and 1 over 5. Okay, let's move on to the last example. So in this last example, you're going to notice that we have the 7x here and we have a 3x here on the other side of the equal sign. So these are two separate x's. So to solve for the x, you need all your x's on the same side. So now you're going to start to see that our rules are fully forming now. So your first absolute step. Move all variables to the same side and all numbers to the opposite side. Okay, so what do I mean by that? Well, you see here I have a 7x and a 3x, and I have a minus 5 and a plus 4. So you can move the 7x to this right side, or I can bring the 3x to this left side. Either way, you're going to get the same answer. So what I'm going to do is I'm going to move the 7x to this side. Now you could have moved the 3x to the other side. It's also the same thing. So I'm going to move 7x to the other side by subtracting 7x from both sides. Now I'm going to do two steps in one here. I'm also going to, since I moved the 7x to that side, I'm going to move the 4 to the other side by subtracting 4 from both sides. Now I'm subtracting 4 because it's already a plus 4 over here. So how do you get rid of plus? By subtracting. So here I'm trying to streamline. I'm trying to do both my steps at once. Okay. So that's going to give me negative 5 minus 4 is equal to 3x minus 7x. That brings you to your second step, which is to collect your like terms. All right. So negative 5 minus 4 is negative 9, is equal to 3x minus 7x, which is negative 4x. That brings us to our next step, which is to isolate x by reverse bedmass. Now you'll notice here that you have this negative 4 multiplying the x, so you want to divide both sides by negative 4. So you're going to have negative 9 divided by negative 4, which is going to give you positive, because negative and negative, 9 over 4 is equal to x. So last step, simplify if you can. So that 9 over 4, you can also turn it into a mixed fraction of 2, 1 over 4. So here we go in this last question, which basically combines everything we've seen in the last couple of examples. So I first want you to try this yourself. So at this point, I want you to pause the video, try it yourself. I assume you've done this and you're back, and if you haven't, I'm sounding quite silly right now. It's okay. So in this question, there are two ways you can do it, and I'm going to show you both ways, but we're still going to follow our steps each time. Okay? So, first way. So your first way is basically isolate all your x's to the same side, and then expand. So that means I'm going to bring this, going to bring this guy to the other side, and I'm going to bring this plus 5 to the other side. And I do that by, well, I'm going to subtract 3x plus 2 from both sides. And to bring that plus 5 to the other side, I'm going to subtract 5 from both sides. So that's going to leave me with 2x minus 3 minus 3x plus 2 is equal to minus 7 minus 5. Now, notice how I said in my second step to collect like terms, but in this case here, I can't collect my like terms yet because they're inside brackets. So that causes me to modify here my steps to add an additional step after simplifying. Through expansion. Alright, so this 2 has to go in, you gotta distribute, you gotta go all Pokemon Go here, so that's going to give you 2x minus 6 minus 3x minus 6 is equal to negative 7 minus 5, which is negative 12. Now you collect your like terms. You got the 2x minus 3x. That's going to give you negative x. You've got the negative 6 and the negative 6, which is going to give you negative 12. Bringing the negative 12 to the other side. So you have negative x is equal to 0. So x is 0. So that's the first way. Second way is to expand right from the get-go. So from the get-go, I'm going to expand. I'm going to have 2x minus 6 plus 5, 3x plus 6 minus 7, and then you're going to collect your like terms from there. Now you can do this all in one step, or you can do it piecewise. Either is fine. So I'm going to have 2x minus 1 is equal to 3x minus 1. Now you want to follow your step number 1, which is you need all your variables to be on the same side. I'm going to choose to bring this 2x to the other side by subtracting 2x from both sides. And I'm going to, if I'm doing that, I'm going to move this minus 1 to the other side by adding 1 to both sides. Alright, so that's going to give me 3x minus 2x is equal to minus 1 plus 1. That's going to give me 0 here. That's going to give me x, which, as you can see, gives you the same answer. Both ways are fine. It doesn't matter which way you use, just whichever way you are most comfortable with. I hope this has helped you in solving linear equations. Have a great day.